Next is limitations of Rutherford model of atom. Limitations of Rutherford model of atom. What Rutherford said? Electrons are revolving around the nucleus in a circular path, right? Yes. But any moving object which is move in a circular path, it will undergo acceleration. Any particle, if it is in a circular motion, it will undergo acceleration. If it is accelerating, then what will happen? It will lose energy, right? Yes. Or we can say it will radiate its energy. Simple example, if I say, consider if you are running in a circular path continuously, then what will happen? You will get tired, right? Yes, you will lose energy. Similarly, this charged particle, that is electrons, when they are moving in a circular path, then what will happen? It lose its energy and will fall into the nucleus. It will lose all its energy and finally it fall into the nucleus. If these electrons then fall into the nucleus, then what will happen? Yes, the atom will be unstable. That means matter will not exist. But you know that atom is quite stable, right? Yes. All matters are stable. Why it is stable? Because atoms are stable. This was the failure of Rutherford model of atom. Okay, this was the first failure of Rutherford model of atom. According to Rutherford, electrons are revolving around the nucleus. That means it undergoes acceleration. Because of this acceleration, this charged particles loses its energy and finally fall into the nucleus. What will happen? The atom become unstable. But we know that atoms are stable. This was the limitation of Rutherford model of atom. Got it, children? Yes. So, the next scientist, Bohr, who put forward a new model of atom. It is known as Bohr's model of atom. Niels Bohr, who tried to overcome the limitations of Rutherford model of atom. What was the failure of Rutherford model of atom? Rutherford concluded that electrons are revolving around the nucleus in a circular path. If the electrons are revolving in such manner, then what will happen? It should radiate its energy and finally fall into the nucleus and atom becomes unstable. But it will not happen. We know that atoms are stable. Okay, it's Bohr who put forward his model of an atom. Okay, and he said that electrons are revolving around the nucleus in a special orbits in a definite energy level called orbits. Okay, electrons revolving around the nucleus in a definite energy level called orbits or shell. So, electrons are revolving around the nucleus in different shells. Okay, here you can see rounded path, right? Yes, circular path you can see here. That is known as shell. Okay, electrons revolving around the nucleus in definite energy level called orbits or shells. Okay, that was the first point. And what was the second point? When these electrons are revolving around in an orbit, then it will not radiate its energy. 2 points of Bohr's model of atom. Electrons revolve around the nucleus in definite energy level. Okay, called orbits or shell. And what was the second point? As long as electron remain in a shell, it never gain or lose energy. Children, can you see in this figure? These are shells, or we can say these are orbits or energy levels. In the center, you have nucleus. Around the nucleus, you have shells. K shell, L shell, M shell and N shell. Here in the case of K shell, here you can see N is equal to 1, right? Yes. because it is the first shell. So n is equal to 1. In the case of L shell, it is the second shell. So n is equal to 2. In the case of M shell, n is equal to 3. In the case of N shell, n is equal to 4. This much is clear, children? Yes. What are the names of shells? K shell, L shell, M shell and N shell. Let's see how these electrons are distributed in various shells.